In the previous video, we looked at how to set up equalities of absolute value. In this video, I want to talk about how to set up the absolute value of inequalities. So this is where it gets a little tricky. So let's just take it down to something very simple. So we can see here that the absolute value is equal to 3. And we found out that that means a measure of distance. And so we got two answers here. We got the answer that x can equal -3 or x can equal 3. So simple enough. But what happens when we have an inequality? So here is an inequality, and I would read it, the absolute value is greater. Now, yes, there's an equal sign there, or 3. So let's keep the words at a minimum. So what would I say? I would say the absolute value is great, and then we have the word or. So this is a or problem, which usually means it follows a certain pattern when we graph it. There are a few exceptions. So let's find out, where is x greater than 3? Well, here we have 4 and we have 5. So clearly 4 and 5 is greater than 3. So that means then that we would be graphing out this way. So our line that graphs goes out this way. So I would put a closed circle and a line with an arrow out that way. But is that the only place where x, the absolute value of x, is greater than or equal to 3? Well, let's find some other values. Let's plug some other numbers down here and let's see. Let's test this number here. This number here is -2. So if I take the absolute value of -2, is that greater than or equal to 3? Well, the absolute value of -2 is 2. Is 2 greater than or equal to 3? And the answer is no. So that value doesn't work. Well, let's try -4. So let's go ahead and put that into our equation and test it. Is the absolute value of -4 greater or equal to 3? The absolute value of -4 is 4. So is 4 greater than or equal to 3? And the answer is yes. So that means everything this side will make this equation true. So everything from -3 to the left is also an answer. Because we have the equals, we're going to put a closed circle here, and we're going to draw our arrow everything to the left. So you can see everything to the left, everything to the right. So this would mean that our answer would be, this is where x is less than or equal to -3, and here is where x is greater than or equal to 3. So if we were going to write this in set builder notation, which I'm going to abbreviate SB, that would mean the set of x such that x is less than or equal to -3, or x is greater than or equal to 3. If I wanted to write my answer in interval notation, which I'm going to abbreviate IN, that means we're going to start as far over to the left as possible. And when we keep going to the left forever, we end up at -infinity, if we could get there. So that means we're going to start at -infinity, and we go all the way until we hit -3. And remember, I have this big gap, so that means I'm going to put this big U, because that's like a big pit, a big gap. Sorry, I did this incorrectly. This is equals to, so I need to put my equals to brace. And then I'm going to start again at 3, so it can be 3, and if I keep going forever to the right, that will eventually give me, get me close to infinity, so to infinity. So this is set builder notation, and this is interval notation. Okay, this means or. It's just kind of a review. This means or. This symbol means equal. Okay, and this means very close. Very close, but it doesn't quite equal it. Okay? So let's look at this example down here. We're going to take the same sort of idea. So we know, notice here that when it equaled, I started at -3 or +3. Here, I started at -3 or +3. And so here, I'm going to have the same sort of thing. Only I'm going to be writing this a little bit differently. Okay, and I'm going to figure out how to show you that in a way that's not going to be too confusing. So I'm just going to go ahead and write my points in there, and I want to figure out where on the graph I am going to be putting my answers. So let's go ahead and let's do a test. We're going to test these numbers that I'm putting in yellow. Okay? So let's test this side first. So if I have the absolute value of 2, is that less than or equal to 3? Well, 2 is definitely less than or equal to 3. So that side works. Because notice if I tried the 4, the absolute value of 4, is that less than or equal to 3? Well, 4 is not less than or equal to 3. So this side doesn't work. So that one didn't work. So I can't go this way, but 2 works, so I can go inward. So for right now, I'm just going to go from 3 to 2. Okay? That's the direction that wants to go. Let's test this side here. So if I have the absolute value of -2, is that less than or equal to 3? Is 2 less than or equal to 3? And the answer is yes. That one worked. Let me try this one. Is -4 less than or equal to 3? So is 4 less than or equal to 3? The answer is no. The absolute value of -4 is 4, and 4 is not less than or equal to 3. So that one doesn't work. So we did say -2 worked, looking here at what we put in. So that means this. So our answers are going to be in the middle, because what happened outside didn't work, but what happened inside did work. And we could test 0. Is the absolute value of 0 less than or equal to 3? Yes. So all the numbers in here, when we test it, will make this statement true. So what I want to do is I'm going to rewrite this to show you how, when we go to solve it, what we'll do. So that means that the absolute value will be less than or equal to whatever this number is. And then this here would be the opposite of the number. Okay? So for example, maybe I'm getting ahead of myself. X is here in the middle, so our solution is right here. So X is here in the middle, and X is greater than or equal to -3, or less than and equal to 3. So that's where I get these numbers here. So when I'm setting this up, I'm going to take my absolute value, whatever that is, let's call it X right now, and that's going to be less than or equal to 3, or greater than and equal to -3. So that's how we would have to set it up. In the next example, I am going to show you how we do these.